Hello all, let's start section 3.3, dividing polynomials, remainder and factor theorems. If you remember from intermediate algebra, one of the easy ways to divide a polynomial on another polynomial is that if you can factor. For example, if I have x squared plus 7x, for example, plus 10 over x plus 2, the easy way is to factor the numerator, and if you can cancel with denominator, you will cancel. For example, the factors of numerator here is x plus 5 times x plus 2, right? And you have in the denominator x plus 2, and easily you can cancel these two and your answer is x plus 5. Or the other way was if you are dividing a polynomial on one term, on a term. It was, for example, if you have x cubed plus 4x squared minus 7x, if you divide this by x, the easy way was to write like this: x cubed over x plus 4x squared over x minus 7x over x, right? And you can cancel here x with x, 2 left, here x with x, 1 left, and here x is gone. Then your answer is x squared plus 4x minus 7, right? Now, today we are dividing polynomials that you cannot maybe factor, correct? And the denominator is also another polynomial, not just a term. We cover those type of dividing today, which we call it long division, right? Today we are learning how to use long division to divide polynomials, correct? In general, division. What is long division? For example, in school, you saw that if I want to divide two numbers, for example, 3,983 divide by, let's say, 26, we call this method long division, correct? Of course, we know that 26, we call 26 divisor. And we call 3,983 dividend. Correct? The method that we divide, we call this method long division. Today, we use the same method and we divide polynomials. But today, we are not dealing with numbers. We are dealing with polynomials. It means our dividend will be a polynomial, correct? For example, like this: x squared plus 10x plus 21. Divide by, your divisor is another polynomial, for example, a binomial, x plus 3. This method of dividing, we call it what? Long division. Now, in a few examples, I'll show it for you how you can divide a polynomial function. I know a lot of students, they think it's a difficult topic, and I saw a lot of them, they have problem to find here the terms, which term, what should be the sign in between. This is the tricky part. But today I'll show you an easy way. An easy way, believe me, it's the easy way. And you can divide any polynomial on another polynomial, correct? I will rewrite this example a little bit here, and I'll explain how to do the long division, correct? For example, x squared, example number 1 of your book, plus 10x plus 21 divided by x plus 3. Before even starting how to show the process, few things that I want to discuss for you, or few notes that I want to put for you, or steps that you have to follow. If you don't follow those steps, you may end up with the wrong answer, correct? Step number 1. Always order the polynomial. Or I can say order the dividend polynomial. Always order. Which order? Usually it's better to order in descending order. Of course, you know what is descending order. If not, I'll discuss it here for you. Always order this polynomial in descending order. You can order it also in ascending order, but usually we prefer descending. Now, what is descending order? What is ascending order, correct? It's very easy topic from beginner algebra. If someone gives you a polynomial like this, for example 2x minus 4x squared plus x cubed plus 4x to the power of 4 minus 1, you see this polynomial is not in an order. First here you have power of 1, then 2, then 3, then 4, then no power, correct? It's kind of mixed. It's not in an order. You can order a polynomial in two ways. The first one that's important for us today is the descending order. What is the descending order? You start with the highest exponent and you write that term first. Your highest exponent is 4 positive 4x to the power of 4. You write that one first. 4x to the power of 4. After that, after 4, you have power of 3. Focus on the sign. You have plus x cubed. Here, plus x cubed. After that, power of 2, you have negative 4x squared, correct? Then negative 4x squared. After that, positive 2x. Then minus 1. We call this order descending. Ascending is this way. If you order this way, starting from negative 1 and go up, it's ascending, going up. Descending, it means from high to low, correct? You are going down. Step 1, order your dividend polynomial in descending order. That's your step 1. Also, in step 1, if your dividend polynomial is incomplete, complete the polynomial, which is not mentioned in your book, correct? Complete your polynomial. How? I'll do an example here. For example, I have 3x to the power of 5 minus 4x plus 3x to the power of 4 plus 3x squared minus 3. Order the polynomial, and if it's incomplete, complete the polynomial. How? I want to do it in descending order. X to the power of 5 is the highest exponent. Okay, 3x to the power of 5 first. After 5, I have to bring 4, right? Plus 3x to the power of 4. And after 4, I should have 3, but there is no power of 3. What you do, add that power, x cubed, to do not change the value of polynomial. Your coefficient should be 0. It means add 0 x cubed. This is how you complete your polynomial, correct? After x cubed plus 3x squared, then minus 4x minus 3. Whenever you want to complete a polynomial, add the missing term or the missing power, but your coefficient should be always 0. And always, I'm telling you, add. It means put a plus sign. Correct? This is how you complete the polynomial function. The other steps are in page 384 that I don't want to write those steps, because if you read those steps, you don't know even what to do. Bring down, multiply this, divide this. I don't want to write those. I'll show it now in an example for you, correct? How to do the division. Now let me start with example number 1. Example number 1 is x squared plus 10x plus 21. Look, my polynomial is in descending order, and also it's a complete polynomial, correct? I don't need to do step 1. Divide by x plus 3. Now, what to write here, that's important. Which number? Some of you are just thinking. Find a number, or some professors are saying this way to you. Find a number here to multiply it with the first term of this. Here, if you multiply, should gives you this term, the first term of dividend. If you want to think it's too much, it's not a number. This example is really an easy one. The coefficient is 1. It's so easy to even think, oh, already I know it's x, right? But in some of them that they are complicated one, even you cannot find this number or the sign. Then how to find that number? I'll show a method for you, correct? How to find that number. To find the first number, and we call here quotient, right? That's your quotient. Whatever you end up with, that's your quotient. To find the first term in quotient, what you do, take the first term of dividend, which is x squared, and divide it with the first term of divisor, whatever the first term of divisor is. And see what is your answer. What is x squared divided by x? X squared divided by x is x. Correct? That is the term that you have to write in quotient. And it's a positive term, right? Here, x. That's your step 1. First term of dividend divided by first term of divisor gives you the first term of the quotient. Now, distribute this term. Distribute, when I'm saying distribute, it means multiply. And write your answer under the dividend, correct? X times x gives you x squared. Positive times positive gives you positive. X times 3 gives you 3x. Now, when we divide, we subtract here in this step, right? And different books, different professors, they show you different method. How to subtract two polynomials. You keep the first polynomial as it is, and you change the sign of the second polynomial. It means you are multiplying your second polynomial by -1. And in the book, or some professors, they just put here a -1, then they subtract. Sometimes you miss it and you write here 2x squared. That's why the mistake comes in and you lose points. Then what is the easy way to avoid that mistake? Instead of writing here -1, focus what I'm saying. This is your second polynomial, the green one. Just change the sign of this to its opposite. X squared is positive, change it to negative. 3x is positive, change it to negative. And focus on the new sign. It means you multiplied this polynomial by -1. It's the same thing. Now add. Positive x squared, negative x squared cancels out. Positive 10x, negative 3x gives you 7x. Focus on the new sign. Correct? Now, what to do? Bring the next term down. Plus 21. Even if I have more terms, bring all of them down. Now I have to divide again, but what to write here? What is the sign and what is the next term? Correct? To find that sign, if it's positive or negative, or what is the next term, again, divide the first term of your dividend, which is 7x, by the first term of divisor, which is x. Correct? And see what is the answer. X cancels out with x, positive 7. It means write down here positive 7. Now distribute again. Distribute 7 to these two. 7 times x gives you 7x. Positive times positive gives you positive. 7 times 3 gives you 21. Now change the sign and subtract. Positive 7x, I'll change it to negative, and this one also negative. These two cancels out, these two cancels out, and you end up with 0 remainder. Correct? It means whenever you divide x squared plus 10x plus 21, even you could factor this one, but I didn't. I just showed the long division. Divide by x plus 3, your answer is what? X plus 7. We call this method long division. I'll do few more examples for you, correct? Then later I show you another easy way. Let's do another example. Example number 2. 4 minus 5x minus x squared plus 6x cubed divide by what? 3x minus 2. First thing, I wanna arrange this polynomial, my dividend, in descending order. It means I will write 6x cubed first, then minus x squared minus 5x plus 4. Oh, why it's too far? 5x plus 4. Now this divide by 3x minus 2. Again, I follow the steps. My step 1 was first term of dividend, which is 6x cubed. I'll go to the corner of my notebook and I divide by 3x and I see what is my answer. 6 divided by 3 gives me 2. X cubed divided by x gives me x squared. Then this is the first term that I have to write here, 2x squared. Even sometimes you are dealing with fractions. These numbers are becoming fractions. They're really easy to deal with. They're really easy to deal with. Whatever this division gives you here, it goes up there. Correct? Now distribute. 2x squared times 3x gives you 6x cubed. Positive times negative gives you negative. 2x squared times 2 gives you 4x squared. Now it's time to subtract. Change the sign. Negative, positive, correct? These two cancels out. Negative x squared, positive 4x squared gives you positive 3x squared. And bring down the other two terms. Bring it down, both of them. No problem. Minus 5x plus 4. In a normal long division with numbers, you bring one number down. But when you are dealing with polynomials, no problem. Bring everything else down, correct? Now, again, my first term, which is 3x squared, divide by first term here, 3x, which gives me what? Only x. Correct? Positive x. I'll write here positive x. Now distribute back this x to this two number, the green arrows, and write your answer here. X times 3x gives you 3x squared. Positive x times negative 2 gives you negative 2x. Now subtract. Correct? It means change the sign first. Negative, positive. These two cancels out. Negative 5x, positive 2x gives you negative 3x. And bring down the 4, plus 4. Should I continue and should I stop here? How I should know if I should continue with my long division or I should stop? As long as, remember again, this exponent, the divisor exponent, and here the remainder exponent is the same or equal, you can go one more time. If you had here, for example, 3x squared, and now you end up with negative 3x, which is your exponent is less than that, here you have to stop. But right now, you see both of them are equal, right? They are equal. Then what I do, I'll do one more time the divide, correct? The first term, divide by first term. Negative 3x, divide by 3x, which gives me negative 1. You see, even it gives you the sign. Then I have to write here negative 1 in the quotient. Distribute. Negative 1 times 3x gives you negative 3x. Negative 1 times negative 2 gives you positive 2. Now change the sign and subtract. Positive, negative. These two cancels out. Positive 4, negative 2 gives you positive 2. Stop here. This is your remainder. Then how to write your answer, your final answer? Your final answer, write this way. 2x squared plus x minus 1, correct? Plus whatever the sign is, here it's a positive 2, here put plus 2 over, bring this one in the denominator. Your divisor goes to the denominator, 3x minus 2. It's the same way that you learn in beginner math, writing a fraction with a complex number, with a number, right? Correct? It's the same way of writing. That will be your answer. This method, we call it long division. Now, there is a shortcut to this method, easier way, which we call it synthetic division. Synthetic division. This division is the easy or shortcut of the long division, as long as your divisor is in the form of x minus c or plus c, doesn't matter which one, but the coefficient of x should be always 1, correct? You can use this division. If the coefficient of x is a number here like ax or bx, a number, then you cannot use synthetic division. You can, but not in this book, correct? We use synthetic division as long as my divisor is in the form of a plus or minus c, correct? How? I'll explain it in an example for you. For example, they are giving me, let's say example number 1. Let's do an example. Four x squared minus 5x plus x cubed plus 5 divided by x minus 3. Again, your first step is to order your polynomial in descending order, correct? Then I'll start with x cubed plus 4x squared minus 5x plus 5. Make sure that this polynomial is complete. 3, 2, look, 3, 2, 1, and 0, correct? It's complete. Now, in synthetic division, we take the coefficient of dividend and we write it in one line, like this. What is the coefficient of x cubed? 1. What is the coefficient of x squared? 4. What is the coefficient of x? Negative 5. And your constant term, which is 5. Draw a box like this on the side. Always choose the opposite sign of this number. X minus 3, choose 3. Or, if you don't remember, always do this. Whatever your divisor is, make it equal to 0 and solve it. X equal 3. Or the easy language, choose the opposite sign. Please remember, choose the opposite sign. If you don't choose the opposite sign, your division is wrong. Correct? Choose the opposite sign. I'll bring down here 3. Now draw a line here. How to start? Bring down your first number all the way under this line. Correct? Here, 1. Now, what you do, look, I'll show you the steps. Multiply this number with this number. Even I'm doing some drawing here for you. 1 times 3 is 3. Where to write your answer? Write your answer under the next column, under this number, under the 4, but above the line. 1 times 3 gives me 3. Write that number above the line. Now add whatever these two number gives you. 4 plus 3, both of them is positive. 4 plus 3 gives me 7. Write your answer here under the line. Now repeat the process of step 1. Multiply again. 7 times 3 gives me 21. I will write in green here under 5. Correct? Now add this two number. Negative 5 and 21 gives me what? 16? Positive 16. Repeat again. 16 times 3. 48. Write down that number above the line, under 5. Correct? And add 5 plus 48 gives me 53. That's your answer. Now, how to write my answer? Focus again. Your first number, if I remove all these arrows, let me first remove these arrows to clean a little bit here. The first number is the coefficient of whatever the polynomial starts. Look, here your polynomial starts with x cubed. 1 less than this. 1 less than this means x squared. Start with x squared. The first number will be the coefficient of x squared. After x squared, you should have x. And after x, constant term, which is 16, right? This one, the last number, is always your remainder. Then, my answer is x squared. The sign of 7 is positive, right? Plus 7x plus 16 plus 53, my remainder, over what? Whatever the original was, x minus 3, the original divisor. We call this method, it's the fastest method. I explained here a lot. It took a lot of time. Maybe you may say, oh, it was so difficult. No, but after practicing one or two, you love this way. Synthetic division is the fastest method, as long as your divisor is in the form of x plus or minus c. Correct? We call this one synthetic division. Let's do a few more examples. Which one? There is another one. 5x cubed, example number 2. 5x cubed plus 6x plus 8 divide by x plus 2. First thing, check your dividend, write it in descending order, and if it's incomplete, complete your polynomial. Okay, 5x cubed first. After x cubed, I should have x squared, which I don't have. Then I'll add 0x squared here. And after that, plus 6x plus 8. Now, write the coefficients in one line. 5, 0, 6, 8. Focus on the sign, please. If it's negative, bring negative. If it's positive, positive. Divide by opposite of this number. Opposite of positive 2 is negative 2. Divide by negative 2. Draw your line. Bring down the first number under the line, which is 5. Multiply these two. 5 times negative 2 gives me negative 10. Above the line under the next column, add 0 minus 10 gives me negative 10. Correct? Again, multiply negative 10 with negative 2, which gives you positive 20 right above the line. 6 plus 20 gives you 26. Again, multiply 26 with negative 2, which gives you what? Negative 52. Under the next column, and add 52 minus 8 should gives you negative 44. Am I right? Negative 44? That should be negative 44 somehow. Yes, negative 44. Now, how to write your answer? Your polynomial starts from x cubed. Then this number will be the coefficient of x squared. This one less, right? I told you one less. This number should be the coefficient of x, and this one should be my constant term, and the last number is my remainder. Then I will write my answer as a 5x squared minus 10x plus 26 minus 44 over whatever the divisor was in original problem, x plus 2. That's your answer. We call this division the synthetic division. Correct? Practice with this. I want to do again short videos, because the next topic I'll talk about the remainder theorem, and after that I'll talk about the factor theorem. They are short, they are easy. Let's finish it in one video because they are not difficult. They are actually the same thing. Next topic that we want to discuss here is the remainder theorem. Reminder. The remainder theorem. What the remainder theorem says. If I have a function f of x. Correct? If you have a polynomial, not function, a polynomial in the form of f of x, and you divide this by x minus c, correct? And the remainder is f of c, your remainder becomes f of c. We call this theorem the remainder theorem. Correct? Where we use the remainder theorem. Look, f of c means f of this number. Correct? That gives you the remainder. It's actually another way. If someone asks you, they give you two polynomials and they ask you to find the remainder, there are two ways, or there are three ways to find the remainder. You can use long division and see what is your remainder. You can use synthetic division and you can find what is your remainder. Remainder means this number, right? The last number. We are focusing on this. You may ask me why this number is too important. Later you see that that number is really important for us when we do, later when we find the zeros of a polynomial function, that number is really important for us, correct? And the third way is to find the f of c, the f of this number. That's exactly gives you this, the remainder, correct? That's why we call this theorem the remainder theorem, correct? I'll show it an example for you. I'll show it an example for you that this remainder theorem is working very well, correct? Example number 1. They are giving you a function f of x equals x cubed minus 4x squared plus 5x plus 3, and they are asking you to find or let's do it, find f of 2. Using the remainder theorem, find f of 2. Correct? Find f of 2. How? Using the remainder theorem. It means you can use the synthetic division. Look, write down the coefficients. You have 1, negative 4, 5, 3, divide by, here they are giving you f of 2. If x is equal to, right? F of 2 means f of x, right? If x is equal to, what is the factor actually? The factor is definitely x minus 2 equals 0. Agree? If it's f of 2, your factor definitely is x minus 2. Correct? Because they told you here f of 2, even no need, but I just explained. Sometimes they give you like this. F of x equals x cubed minus 4x squared plus 5x plus 3. Divide by x minus 2. Find the remainder. Immediately you have to find f of opposite of this. That's why I explained. Here it's given, no problem. But if I give you like this, x divide by x minus 2, then find the remainder. You have to look for the f of positive 2, not negative 2. Correct? That's why I explained it here. Put the 2 here and do synthetic division. Bring down 1. 1 times 2 gives you 2. Negative 4 and 2 gives you negative 2. Negative 2 times 2 gives you negative 4. 5 negative 4 gives you 1. 1 times 2 is 2. And 3 plus 2 is 6. My remainder is 6. If you say no, it's wrong, let's do this. F of x equals x cubed minus 4x squared plus 5x plus 3. Let's find f of 2. F of 2 equals 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3, which gives you 8 minus 2 squared is 4. 4 times 4, 16 plus 10 plus 3. Positive 10, positive 3, 13. 13 plus 8, 21. Minus 16, which gives you what? 21 minus 16, 21 or 22? Hi, it's not 6. Look at me. 3 plus 2 is not 6. 3 plus 2 is 5, right? You can send me back to elementary school. 3 plus 2 gives you 5, not 6. Okay, 21 minus 16 gives you again 5. You see this number and this number is the same. If you do the synthetic division or you find f of 2, they are the same. Here you have to do a lot of calculation. They are easy to do a mistake. With synthetic division, it's really easy to find the f of 2. Okay? We call this the remainder theorem. Correct? The next topic is the factor theorem. Factor theorem. If you have a function f of x, correct? If f of c, which is a number, is equal 0, then x minus c is a factor of f of x. Is a factor of f of x. I talk here in algebra language. Now I'll explain it to you. F of c is your remainder. If your remainder becomes 0, then x minus c, which is your divisor, that is a factor of the polynomial function f of x. If your remainder, when you do dividing, if your remainder doesn't become 0, it's not 0, that number or that factor, that binomial is not the factor. It's very important theorem. Even we use this later in an example. You see, I will use this theorem to find to factor a polynomial that easily you cannot factor, right? It's a cube polynomial that you don't know even how to factor. I'm using synthetic division and I will factor it, correct? B, this is A. B, F, x minus c, which is your divisor, correct, is a factor of f of x. It's the opposite way of A, right? What I write there. Then, of course, f of c is equal 0. Actually, these two gives you the same meaning, A and B, right? It's the other way of explanation. If your divisor is a factor of your polynomial, then definitely your remainder becomes 0 when you divide. Correct? Let's use this theorem where we use it. Let's see. Example number 1. Solve the equation, or just I'll write here solve. Even it's not a function, they give you an equation. 2x cubed minus 3x squared minus 11x plus 6 equals 0 given that given that 3 is a 0 of f of x equals same thing, 2x cubed minus 3x squared minus 11x plus 6. 3 is a 0 of this function. It means 3 is x minus 3 is a factor, right? Because if you make x minus 3 equals 0, it gives you x equal 3, which is one of the zeros, right? One of the x-intercepts, correct? If 3 is one of the factors, or one of the zeros of this function, solve this equation. Then it's really easy, right? I need to factor this equation. Let me rewrite here 2x cubed minus 3x squared minus 11x plus 6 equals 0. You see, even you cannot factor. Then how to factor it? They give me a good hint. 3 is a 0 of the function, which the function is the same as my equation. It means I can do synthetic division here. 2, negative 3, negative 11, positive 6. Oh, why I put a plus sign there? Positive 6. Positive 6 divide by what? 3 as a 0 divide by 3. Let's do the synthetic division. You see, immediately you can factor this. Bring down 2. 2 times 3 gives you 6. Negative 3 and 6 gives you 3. 3 times 3 gives you 9. Negative 11 and 9 gives you negative 2. Negative 2 times 3 gives you negative 6. You see, here remainder 0. If the remainder is 0, then x minus 3 is a factor, right? What is the rest of this polynomial function? Here you have x cubed, start with x squared, x and number. Then you can write that equation like this. One of the factors are x minus 3, right? The opposite of this sign. X minus 3 times, what is the rest? 2x squared plus 3x minus 2 equal what? 0. Now here you can factor this quadratic, right? It's easy to factor this quadratic. X minus 3 times 2 parentheses. The first one, 2x and x. Now here I'll put 2, here 1, right? Because minus 1 and plus 2 gives me 3x equal to 0. Now set each parenthesis equals 0 and you can solve this equation. X minus 3 equals 0, it means x equals 3. 2x minus 1 equals 0, it means 2x equals 1, it means x equals 1/2. X plus 2 equals 0, it means x equals negative 2. You solved a cube equation. a cubic equation, 3 answers. By helping this hint that they gives you, 3 is a zero of this function. It means 3 is a factor, which is x minus 3, correct? There is another trick, another function on page, another equation 391. I lit that one for you to solve. It's f of x, it's 15x cubed plus 14x squared minus 3x minus 2. Checkpoint 6. You can do that one by yourself, but if you have question, of course, today, Wednesday at 3, I changed my office hour from Tuesdays to Wednesdays because Tuesdays I got another class and I got busy. Wednesdays at 4 o'clock I'll be online for your office hour. I put an announcement for you, and if you go to your confer Zoom, you will see my office hour is already set there. If you have a question, you can come online on Wednesdays at 4 and you can ask me question, correct? I'll stop the lecture here. That was all about 3.3. And see you in section 3.4, which we will discuss the zeros of a polynomial function.